Hi, in this last video I'm gonna talk about uniformly continuous. In mathematics, a function f is uniformly continuous if, roughly speaking, it is possible to guarantee that fs and fy be as close to each other as we please by requiring only that x and y are sufficiently close to each other. Unlike ordinary continuity, where the maximum distance between fs and fy may depend on x and y themselves. So, where a function is uniformly continuous if we don't take a fixed point and then see if we can always find delta for every epsilon. Instead, we need to see if it works for every pair of points in the domain, and the best way is to show the visual example. So in this case, we want to guarantee that the image of those 2 points fall within epsilon, and we have a delta that if those points are going to always be in the delta range, then we know that the image are going to be fall on the epsilon range. But it's not enough to just show it for those 2 points. We have to show it for every point in the function. So in this case, we have another 2 points further down in the function. We have to guarantee that if they are within delta, then the image are going to be within epsilon. I understand the geometric difference between continuity and uniform continuity, but I don't quite see how the difference between those two are apparent from their definition. For example, definition for continuity: a function f a approach R is continuous at a point C element A if for all e bigger than 0 there exists a delta bigger than 0 such that whenever x minus c is smaller than delta and x element A, it follows that fx minus fc is smaller than e, smaller than 11. While uniform continuity is defined as a function f a approach R is uniformly continuous on A if for every element is bigger than 0 then exists a delta bigger than 0 such that x minus y smaller than delta implies fx minus fy is smaller than element.